Welcome back. After learning theoretical aspects of deep learning, this unit is all about some practical aspects. We will explore when to use deep learning versus traditional machine learning, where to find data and models, how to annotate data, and the benefits of pre-trained models. We will also highlight some key platforms and websites essential for AI work. Deep learning is at the forefront of innovation, offering great capabilities for handling diverse and unstructured data types. Whether it's identifying objects in images, understanding human speech, or generating text, deep learning can excel at tasks where traditional machine learning methods struggle. However, it is important to understand that deep learning is not a one-size-fits-all solution. While it works well on complex, less structured data, traditional machine learning can outperform it on structured datasets. Deep learning works well on high-quality labeled datasets, which are essential both for training models from scratch and for benchmarking performance. These standard datasets often come from scientific journals or large corporations. Examples include MNIST for handwritten digits, Fashion MNIST for fashion items, and Open Images with 15 million annotated boxes across 600 classes. Many of the standard datasets come bundled with machine learning and deep learning libraries. For more specialized needs, platforms such as Kaggle, Hugging Face, or OpenML offer a wide range of options. To create a dataset for AI training, you not only need a lot of raw data, you also need to label it. From identifying objects in images to annotating text and audio samples, labeling is one of the backbones of AI development. Popular tools for labeling include commercial options like SuperAnnotate, RoboFlow, Landing AI, or privacy-preserving open source options like MakeSense.ai or Label Studio. Because training deep learning models requires a lot of data, time, and computing resources, the best choice is often to fine-tune an existing model for your specific problem. Some popular pre-trained networks like ResNet or AlexNet for image classification are already part of deep learning libraries like PyTorch or Keras. Just as with datasets, there are also AI community platforms that host thousands of pre-trained models. The most popular example is Hugging Face. Platforms like Ultralytics or Landing AI even offer an easy-to-use web platform where you can label your data and fine-tune existing computer vision models to your own data. But how does model fine-tuning actually work? When we start with a pre-trained model, it already comes with weight factors, having been trained on a broad range of data spanning various classes. Now, when we need to address a specific problem that involves classes not covered in the original training, we follow a process. First, we freeze the initial layers of the model. This means their weight factors remain unchanged during training. Then we focus solely on retraining the final classification layer to adapt to the new class. Alternatively, we might also adjust the inner layers of the network, tweaking them to better suit the specific task at hand. This optimization process ensures the model is fine-tuned to meet the unique requirements of our particular problem. Congratulations, you have gained insights into applications and practical considerations of deep learning. Armed with knowledge about typical use cases, training data acquisition, labeling techniques, and pre-trained models, you are well equipped to embark on your AI journey with confidence.